Creepy crawly Jew, a red Goliath star, is one of the most captivating items in our universe. Assuming it were put where our sun is, its huge size would loosen up to the circle of Jupiter. This Goliath star is profoundly shaky and near the very edge of detonating, making it quite possibly one of the most critical sources of radio energy in the universe. Betelgeuse produces more energy than a billion suns. Its monstrous size and unsteadiness have interested space experts for quite a long time. Situated in the constellation Orion, Betelgeuse has shown surprising conduct as of late, like huge darkening and vicious vibrations, which have prompted hypotheses that it might soon detonate in a cosmic explosion. However, there is also the possibility that we may witness a much more frightening event: the breakdown of Betelgeuse into itself. This potential breakdown could have significant implications for the future of the universe. Betelgeuse, with a size 950 times bigger than our Sun, is one of the biggest stars known. Notwithstanding its magnificence, its enormous size means it has a limited life expectancy and is basically a ticking delayed bomb. Located around 650 light-years away, Betelgeuse charms stargazers who wonder about its brightness and look to disentangle the secrets stowed away inside its red-hot depths. Albeit only 133% of its brilliant energy is visible to us, if we could see its full splendor, it would surpass even Sirius, the most brilliant star in our night sky. Imagine a star with a range multiple times that of our Sun, extending past the asteroid belt and nearly reaching Jupiter. In this immense domain, Earth, Mars, Mercury, and Venus would be inundated by Betelgeuse's astronomical appeal consistently. Betelgeuse sheds a solar mass, pushing off its divine remnant in a breathtaking display of heavenly venue. A cloud 250 times bigger than the actual star envelopes creepy crawly juice, covering it in an ethereal fog that dazzles our gaze. This cloud extends 30 galactic units, welcoming us into a grand dance of marvel and enticing us to uncover its secrets. As the universe continues to advance, Betelgeuse's looming cosmic explosion remains a signal of both scientific interest and cosmic display. This monstrous star, with its erratic behavior, gives a fascinating opportunity for specialists to study heavenly evolution. The cosmic explosion event is supposed to be a crucial moment in the life cycle of Betelgeuse, possibly offering insights into the end phases of gigantic star advancement and the cycles that drive such disastrous events. The core breakdown of a red supergiant like Betelgeuse can create an assortment of interesting phenomena. When the star depletes its atomic fuel, the core contracts under gravity, prompting an extraordinary increase in pressure and temperature. This cycle can set off a supernova blast, catapulting the external layers of the star into space and abandoning a thick remnant. Depending on the mass of the leftover core, this remnant could turn into a neutron star, or if sufficiently gigantic, collapse further to form a black hole. As a result, Betelgeuse's cosmic explosion won't just be a display for cosmologists, but also an essential event for understanding the elements of such blasts. Supernovae are critical to the formation of elements heavier than iron, which are scattered into space and contribute to the material that forms new stars, planets, and even life. The leftovers of Betelgeuse's blast will enrich the interstellar medium with these elements, continuing the cycle of heavenly birth and death that shapes the universe. Notwithstanding its impact on astronomy, Betelgeuse's cosmic explosion will provide a natural laboratory for studying the effects of such blasts on their environmental elements. The shock waves from the cosmic explosion will interact with the surrounding interstellar medium, creating a pulsar wind cloud or a supernova remnant. Depending on the blast's characteristics, these interactions can trigger the formation of new stars and planetary systems within the cloud, exhibiting the intricate connection between heavenly death and rebirth. Observing Betelgeuse's advancement in the lead-up to its cosmic explosion will offer valuable information on the last phases of a star's life. Specialists will monitor changes in the star's radiance, spectral lines, and various attributes to better understand the processes that occur shortly before a blast. Such observations are crucial for refining models of heavenly evolution and supernova mechanisms. The data gathered could also help explain variations in supernovae observed in different parts of the universe. The effect of Betelgeuse's cosmic explosion on Earth will be insignificant given the star's distance from our planet. However, The event will likely have scientific and cultural significance for space experts. It represents a rare opportunity to observe a cosmic explosion in a relatively nearby star system, providing a clearer perspective on the blast's elements and repercussions for the public. It will be a tremendous divine event, igniting interest in cosmology and space science. Social reactions to galactic events have generally ranged from awe to myth-making. As Betelgeuse moves toward its end, its possible cosmic explosion will likely inspire another wave of social and artistic expressions, from literature to visual arts. The dramatic imagery of a dying star and its volatile finale will capture the imagination of people around the world, continuing a tradition of celestial events shaping human creativity and thought. Concerning mechanical advancements, the observation of Betelgeuse's cosmic explosion will push the limits of current astronomical instruments and methods. Stargazers will likely send advanced telescopes and space observatories to monitor the event, capturing detailed images and spectra of the blast. The information gathered will enhance our understanding of heavenly processes and could lead to improvements in observational techniques. The cosmic explosion of Betelgeuse will also serve as a case study for examining the behaviors of different types of supernovae. By analyzing the characteristics of Betelgeuse's blast and comparing them with other supernovae, researchers can gain insights into the factors that influence the explosion's outcome. This comparative analysis will help refine theoretical models and improve predictions of supernova properties, ultimately enhancing our understanding of the life cycle of massive stars. Besides, Betelgeuse's possible blast will likely become a reference point for future investigations of heavenly death and cosmic explosion phenomena. As one of the most anticipated supernovae, its observation will provide a benchmark for future research and help guide inquiries into the end phases of heavenly advancement. The information gathered from this event will be significant for generations of astronomers and astrophysicists. The investigation of Betelgeuse and its looming cosmic explosion highlights the interconnectedness of the universe. The life cycle of stars, including their explosive deaths, plays a crucial role in shaping the cosmos. By understanding these cycles, we gain insights into the formation and evolution of galaxies, the distribution of elements, and the potential for life elsewhere in the universe. In summary, Betelgeuse's cosmic explosion promises to be a milestone event in both observational astronomy and astrophysical research. Its impending blast offers a unique opportunity to study the last phases of a massive star's life and the resulting influences on the surrounding space. As cosmologists prepare for this rare event, the anticipation underscores the dynamic and ever-evolving nature of the universe. The scientific and cultural significance of Betelgeuse's cosmic explosion will resonate long past the event itself, continuing to inspire and inform our understanding of the universe. As we dive into the core of Betelgeuse's creation, we find that the stellar chemistry of hydrogen fusion ignites and produces helium, triggering a massive explosion. Over time, the star's hydrogen fuel diminishes, leading to a stellar transformation where helium intermingles with carbon, releasing a brilliance that spills across the universe. As neon combines with iron, a remarkable change occurs. The star's gravity, released by the absence of energy production, triggers an impending collapse, steering Scarab Juice toward a fate that is both dazzling and disastrous. A cosmic explosion, a blast in the realm of cosmic phenomena. Supernovae will be no exception. With the energy of 10 billion suns, this giant divine entity will unleash a force that resonates throughout the universe, leaving us in awe of its incredible potential. Throughout the ages, stars undergo a mesmerizing transformation, progressing from the vibrant blues of youth to the searing reds of maturity. During the 2nd century BC, Chinese astronomers noted Betelgeuse's distinctive yellow tint, which stood out from the celestial tapestry. As centuries passed, Roman astronomers recorded Betelgeuse as having an orange or rosy appearance. This characteristic still captivates our attention today, with its consistent color across various civilizations, including medieval observers in the Middle East, adding to the intrigue surrounding insect Jew. In 2019, Creepy Crawly Juice surprised researchers by suddenly diminishing in brightness. Initially, it was thought that a massive dust storm released from the star's surface obstructed our view. However, the origin of this cloud remains unclear. Some researchers speculate that a large object, such as a planet, could have disrupted the star's surface or even been consumed by it. Recently, Betelgeuse has become nearly half brighter than its average brightness. A surprising event since stars generally become dimmer as they age. Researchers are uncertain about the reason for this abrupt increase in brightness. However, they know that a star's brightness can vary based on multiple factors. For example, some stars undergo cycles of bright and faint phases, like the star Algol, known for its regular variations in brightness. Deep within Betelgeuse, a seismic shift occurred. The explosion of burning material sent into space created a glorious dust cloud, obscuring a significant portion of Betelgeuse's brilliant light. This transformed it from a stunning beacon to a muted luminary presence in the night sky. Once among the 10 brightest stars, Betelgeuse now ranks lower than the 20th brightest. This dramatic change in brightness has piqued the interest of researchers and stargazers. Overall, some theories suggest that large sunspots or dust clouds might be responsible, while others consider the possibility of oscillating cycles. Research has even proposed that Betelgeuse's cosmic explosion might have already occurred. While moderate estimates predicted Betelgeuse's cosmic explosion event to be countless years away, evidence now suggests an alternate story. Scientists have proposed a model indicating that Betelgeuse might be in the late phase of carbon burning, making it a strong contender for the next expected cosmic explosion event in our Milky Way. However, understanding Betelgeuse is akin to piecing together a puzzle with conflicting observations. There are signs of material ejections and subsequent recovery, leaning towards a mass ejection event, albeit smaller in scale compared to our Sun. Supernovae are real phenomena, as evidenced by the one observed in a satellite galaxy of the Milky Way in 1987. While estimates for Betelgeuse's blast timing remain uncertain, it is not time to plan a vacation around it. Right now, the challenge lies in the difficulty of observing Betelgeuse. Despite researchers studying it for centuries and finding that its brightness changes over time, there isn't enough evidence to predict exactly when a cosmic explosion could occur. A cosmic explosion is a brilliant blast that happens when a star dies, and it isn't destructive to life on Earth. The brightness of a cosmic explosion depends on the size of the star that detonates. Betelgeuse's cosmic explosion would be extremely bright, comparable to the light of a half-moon and visible during the daytime. However, the brightness of a cosmic explosion would also pose a challenge for cosmologists. The blast would be so bright that it could obscure the view of other stars and planets, making it difficult to study the night sky. One possibility is that Betelgeuse consumed a massive object, such as another star, which could have accelerated its evolution and increased the likelihood of a cosmic explosion. A recent paper suggests that Betelgeuse's brightness cycles, especially the longest period of 2,200 days, could be the primary cycle for its throbs. If this is correct, the star's brightness could change dramatically from here on out. This remains a hypothesis, and more research is needed to confirm it. Despite the potential challenges, the brightness of a cosmic explosion would be a mixed blessing. It would be a magnificent and thrilling event to observe, yet could also complicate observations for astronomers. Betelgeuse's potential to go supernova offers a unique opportunity to capture its essence in stunning detail. Unlike distant twinkling points of light, Betelgeuse reveals itself as a brilliant disk through telescopes, inviting us to witness its iridescent variations and grasp the subtle dance of its light. The cosmic explosion display won't disappear quickly. It will linger in our night sky for years, gradually fading like a distant star. There might be moments of renewed brightness before its light gently scatters. While the cosmic explosion poses no danger to us, it could baffle creatures that navigate by the moon's glow, as the additional cosmic light could disrupt their nighttime habits. Cosmologists will face new challenges in studying the universe, as a bursting cosmic explosion will add complexity to observations during twilight periods. Nevertheless, the allure of this divine spectacle will draw the attention of countless telescopes and specialists, who will eagerly adjust their observations to capture the magnificence of Betelgeuse's final act. The anticipation among cosmologists and stargazers is palpable as they await the grand spectacle of Betelgeuse's cosmic explosion. Earth is safe from harm, as Betelgeuse is located at a comfortable distance. The cosmic explosion won't overshadow the moon or the sun, but will cast an ethereal glow, illuminating our nights and making its presence known during the day for an entire year. Imagine the enchanting sight of creepy-crawly juice's brilliant remnants casting delicate shadows upon our world. This cosmic presentation will unfold over many years, initially stunning us with its brilliance before gradually fading into the night sky. There might be moments of renewed glow before the star disappears, leaving us with cherished memories of its celestial splendor. Researchers have found that Betelgeuse's brightness cycles are similar to those observed in stars approaching the end of their lives, suggesting that Betelgeuse could go supernova soon. If it does, it would be the closest cosmic explosion to Earth in hundreds of years. The blast would be visible to the naked eye and extraordinarily bright. However, this remains a theory, and more investigation is needed to confirm when Betelgeuse will go supernova. Regardless of whether it does, it is unlikely to be dangerous to Earth, as the star is around 550 light-years away. The only observable effect would be a burst of neutrinos, minuscule particles that don't interact with matter and pose no threat. Following the neutrino burst, a very bright object would appear in the night sky, akin to the brightness of a full moon. This brightness would last for weeks before gradually fading. The blast would also release dust and gas into space, which could obscure some light from other stars and cause temporary environmental changes, although the impacts would be relatively minor. While this celestial event won't pose a direct threat, it might complicate animals that rely on twilight for navigation. The brightness of the cosmic explosion could disrupt their nighttime behaviors and confuse their regular navigation strategies. The increased light could also affect nighttime ecosystems, as the extra illumination could disrupt the natural patterns of various species. Creepy-crawly Juice's potential cosmic explosion holds a special place in the grand tapestry of astronomical events. Its ability to illuminate our night sky and spellbind our imagination offers an opportunity for scientific discovery and public wonder. As space experts eagerly speculate about this astronomical display, we are reminded of the profound beauty and dynamic nature of the universe. The looming cosmic explosion will serve as a divine reminder of the universe's ever-changing nature, filling our skies with a brilliant yet fleeting show of astronomical glory.